All right. So you said homework, no issues? Okay. Today we're going to do something and don't panic. Don't panic. All right? You're not going to panic? Okay. There are how many problems?
Does that mean it's easy?
You got 6 there.
No, there's only a few problems.
Yeah,
Is
it's
it
a lot.
problem?
It's all, yeah.
All of these are,
You got 8.
you got 8 problems, and they're all word problems.
Word.
I just said don't panic, and immediately you panic. Okay. So I'm going to give you 6 examples, except we'll probably only get to 5 of them, right? Last class I did it, I could only get to 5, and I thought the pace went pretty good. We'll do at least 5 of them. If we get to the 6th one, then you're responsible for the 6th one. If you don't get to the 6th one, you're not responsible for it. There's 8 problems, but they come in different flavors. I've tried to choose an example of all the flavors tonight for homework. The key to doing every one of these word problems is a good picture. With a good picture, you're going to wonder why I made such a big deal about today's class. With a bad picture, these are really challenging problems. But with a good picture, it's not that bad. So I've taught this class now for a couple of years, and the technique I usually choose with small classes, everybody gets a problem, right? So you get to be on the hot seat to see how this works. Unfortunately for Leaf and Ish, right, I do have diagrams of this, but I'm going to let the kids talk first. I will draw on the board. I'll show you the picture as compared to what's in the book. And so for you guys, you'll just have to hear the words. You may not even hear what the kids are saying, but at the very end, you'll see the picture. It'll make sense. I'll show you the math behind it. Okay. All right. So you guys all get a pick. Who goes first?
Oh, yeah, I agree.
Who goes first?
Or not, no. I mean,
Do you want to know which one's the easiest one?
The first one.
So who wants to go first?
let Seth go first.
Why me?
All right.
Oh.
This is being recorded.
Says
So
you
no.
got a D on there too.
That's
All right. Seth, you're going first. Okay. In other words, we're doing trig problems, but they're going to be word problems. All of them are going to be word problems. So go ahead and throw your little hissy fit.
You know what, that was Caden this morning, because I bought him a vest.
Yeah.
A bulletproof vest.
And he didn't like it?
No, Christina said that the size was gonna be too small, and I was like, no, it's perfect, it's gonna fit him good. And then she told me to take it back, but then he tried it on and it fit him perfectly, and then this morning, or he wore it last night, and then he got food all over it.
Oh, he couldn't wear it. Oh, he was upset. Okay. So we're just doing word problems that all involve trig. The easy trig, the trig from last night, the trig that you just stated was like it wasn't that big of a deal. All right. So remember the basic trig, right? Right triangle trig involves SOHCAHTOA. We can place it on the unit circle if we'd like. Instead of A, B, and C, we get X, Y, and R. Right. So for all the 6 trig functions, and notice we don't really need cosecant, secant, cotangent. We can get it from sine, cosine, and tangent. But if you'd like to use cosecant, secant, cotangent, you can. All right. We only in basic trig only are doing 2 things. We're solving for a side or we're solving for an angle. Solve for a side, I need an angle and I need one side. An angle, one side at a minimum. You can have more stuff, but in order to solve for that X right there, I need one angle, one side where the angle is not 90. Solve for an unknown angle, I need at least 2 sides. You can have all 3, that's fine, but I have to have at least 2 sides. So what's the process? Well, it's just trig. Remember, we're solving for a side, it's the normal sine, cosine, tangent. We're solving for an angle, it's inverse sine, cosine, tangent. Okay, quick examples. This is the same thing from yesterday. Let's see, if I'm solving for C, C is a side, I need one angle and one side. I got one angle, one side. The angle's 40, the side is 2. So we set up, let's see, C is your hypotenuse, 2 is your adjacent, so that's cosine. Cosine of 40 is equal to 2 over C. Solve for C, multiply both sides by C, and now divide by cosine. Plug that into your calculator, round, you get your answer. I'm doing this quick because it's the same slides yesterday. We can solve for A now, right? Using tangent, I already showed you the answer, right? When the variable is on the top of the ratio, it's really simple. By the way, most of you should probably have this pattern memorized. Like from the initial setup, you know, hey, am I dividing by the tangent or the sine or the cosine, or am I just doing the side times the sine, cosine, or tangent? And if you do a bunch of these, you get that memorized. All right. Solve for an angle. Somebody said yesterday, hey, look, if they give you one of the angles, do it the easy way, subtract it from 90. But if you forget that, well, then we use inverse, whatever the trig function here. In this case, we'll use side A, which is 1.68, and side the long leg right there, which is 2. So opposite over the adjacent. We do the inverse tangent of both sides and plug it in a calculator. We get to 50 degrees. Okay. So that's just a reminder of basic trig. So today's class is on word problems, right? It's just 6. We'll probably get to 5 of them. Or we will get to 5 of them. I don't know if we'll get to the 6th one, right? Ready? Right. Every person's going to get one problem, right? So the only challenging thing is to draw the picture. Draw the picture. You have to read words and draw a picture. And then it will look like last night's homework. It'll be some trig. You're either solving for a side or solving for an angle. All right. Seth, you got box number 1. You're up first. Read.
A surveyor can measure the width of a river by setting up a transit at a point C on one side of a river and taking a side of a point A on the other side.
All right. Stop and tell me what you don't get, what you don't understand from that one sentence. Do you know what a surveyor is? Do you know what a surveyor is? Yes or no? Yeah, but what is a survey? What do they do? No. Oh, yes, I get what you're saying. No, that's not what this is. A person who conducts a survey is not a surveyor in the sense. This is a person who, you've seen them on the side of the road. They don't build or construct anything. They survey. So what do they survey?
Watch.
Anybody know what a surveyor is? Show you a picture of one, right? There's a surveyor right there. Surveyor is this dude here on the left. He's got nice clean clothes, right? He's looking through some sort of instrument. The instrument looks like a camera or a telescope, right? Guess what this telescope is called? It's called a transit, right? So this is what's called a transit. Guess what a transit measures?
Distance.
Distance, it's got a laser in it. Angles, it measures 2 angles. Guess which 2 angles?
90.
No, guess what 2 angles it measures? What is he looking at?
How?
It's the picture on the right. What is he looking at? What is he looking at? Look at the picture. He's looking at some monkey handing a pole, right? So this person right here is the guy that's all dirty, right? The surveyor is always clean. Maybe his boots are dirty, but he's always clean. He's got the $10,000 transit in his hand, and he has his assistant to go out there in the distance and hold this pole. So what is the surveyor looking at? The pole. And the pole marks a specific distance or specific location in space. So for instance, when this building that we're in right now was built, we had to lay out the corners of the building first. Well, how do they find those corners? With a transit. So you put this somewhere in a known location. It's got to be a known location. Like we start with one corner of the building. Now we got to find the other 3 corners. So we know that we want it to be at right angles. So he turns his transit 90 degrees and he points it in a specific distance. He knows how long the building's supposed to be. He shoots his laser rangefinder. He tells the dude, further, further, left, right, forward, that sort of thing. And when he finally finds the spot that's by the blueprints, the exact same spot, then he puts the stick down and he marks it. That's what surveyors do, right? Transit measures 2 angles. Which 2 angles? You can kind of look at the picture and figure it out. What 2 angles could that measure? I'm not talking about a number. I'm talking about what kind of angles, not obtuse or cube. What 2 angles could it measure?
Well, because it's going straight.
So what 2 angles?
Angle.
Easy words. Easy
A.
words. Kindergarten.
the corner angle, the top angle, and the bottom.
Look at the telescope. What do you think it's doing?
It's going straight, and so he's finding the.
The
angle
telescope moves in which directions?
Up and down.
So it measures up and down angles and left and right angles. Isn't that what you would need, right? Hey, I want my building to be level. So you got to figure out what level is. That's up and down. Hey, I got to put that corner post where it needs to be the right distance, and the left and right the right distance. So it turns left and right, and the telescope moves up and down. That's transit. All of that is just background information to draw our picture correct. Because if you don't know what a transit is, this is kind of challenging. All right. Now I got to take that sentence and I got to draw something. Seth, read the sentence again really quickly to yourself. Tell me what you need to draw. Well, how do I know where to put 2 points? What do you think the first thing I should draw? Yeah, but the line, how do I know how long to make the line? What do you think the first thing I should draw? Read the sentence. Stop looking at me. What do you think the first thing I should draw is? I'm going to say the first thing you should draw is the thing you're measuring. What are you measuring? So I should draw a river. So how am I going to draw the river? He wants me to draw a squiggly, squiggly line. Okay. Squiggly, squiggly line. That's the river. Read the last sentence.
Setting up the transit at point C on.
Last sentence.
Last one.
Yeah.
What is the width of the river?
So should I draw a squiggle? Well, how are you going to measure the width of that little black line right there? Maybe just, it's a river. Think this through. We're trying to measure the width of the river. I got to draw that. So instead of drawing a wiggly line, I should probably draw 2 wiggly lines, right? Because I want to measure the width of the river, right? Does that make sense? The hardest thing about today is the picture, right? So this is going to be hard. Once we get to the trig, that's going to be easy. But the picture is going to be the challenge. Okay, I got my river. Now what do you want me to draw?
Set point C on one side.
Mm-hmm.
Put a point down.
Now, doesn't that make a bit more sense? Now we know where to put A and C, right? Because I got the river drawn. So where do you want me to draw them? Use words.
C should go.
So C on the top doesn't matter where I put it. Okay, so where do you want me to put it? Okay, so he says put C right here. Once again, ish and a leaf. It'll make sense. I'll show you the picture here at the end. Okay, to the left or right or directly below it? How do you know it's directly below it? Yeah, but how do you know it's? We're measuring the width of the river. How do you measure a width? The shortest distance between 2 points is a straight line, right? So if I put point C right here, I'm not really measuring the width of the river. The width of the river would be directly across, right? That's why I know it's directly across, because I'm measuring the width of the river. Okay, now what do I draw? Oh, by the way, where are you standing at, A or C?
B.
Where are you standing at the start? It says a surveyor can measure the width of the river by setting up a transit at point C. Okay, so we're standing at C. Now what?
You're turning.
Does it say which direction? So which way do you want to turn? So we're turning to the right 90 degrees and then?
Walks a distance of 200.
So 200 meters to point B, and B is on it. Now, we're going to assume that it's not as curvy as it is, otherwise we don't get a right triangle, right? So we're going to assume that it's more of a straight river, okay? So it's more of a straight river, like that, okay? So how far did we just walk to point B?
2.
So this line right here is 200, yes? Okay, now what? So what? It's 20 degrees from B to where? So if it's to the other side of the river, that's 90 degrees. So it's 20 degrees from B to where? So it says he moved his transit point to point B, which is 200 meters down. 20 degrees from B to where? To A. So we now know that there's my triangle and that's 20 degrees, yes? Okay, what are we trying to find? So where's that? So we got to give it a name. That's a segment. We got to give it a name, just that one value. We probably wouldn't call that A, but how about X? Technically, we probably should call it little b because it's opposite big B, right? Okay,
Is this like the depression in horizon?
not yet. We'll get there. Are we have enough information to solve this? Do we have enough information to solve this? Are we solving for a side or an angle? A side, come on, let me tell you. So a side requires you to have what? It was the first slides. Do we have a side and an angle? So we can now use trig. Okay, give me the names. There's your 20 degrees, give me the names. Yep. So what are the names here? And the other side would be the, so which trig function? Opposite and adjacent. 10. So let's do it. Tan of what angle? 20 is equal to opposite, which is over 200. And you just did this last night for homework, so what do? Okay, grab your calculator, tell me the answer. Does that sound like a reasonable distance? He got 70 meters roughly. 70 what?
72.
72.8. Does that sound like a reasonable answer? Look at the triangle. If this side is 200, could this side be 70? What would be an unreasonable answer?
5.
If it was 5, if it was 5,000, unreasonable answer. All right, you want to see if your picture matches what they did in the book? Right, here is the picture in the book. What's different? We just assumed that we were on the top of the river. They assumed that you were in the bottom of the river. Is it the same picture? Yeah. So we did we do it right? We did. Okay. So for Leaf and Ish, now you didn't get to see the picture we drew. I was just upside down, but we basically had that exact same picture right there. And then we did this math right here. And we got the same answer, 73 meters approximately. Okay, pause the video if you need to. We're moving on to the next one. Oh, makes sense, everybody? Okay, cool. Who's next? Who's next? You're getting a hard one. We're not giving you an easy one. Oh, I just said it was easy. Who wants this one? Priscilla? All right.
Wait, he had his hand up.
That means you're going to get a more challenging one, Priscilla.
That's okay.
Okay. All right, Nick, you're up. Read.
A straight trail from the Alpine Hotel, elevation 8,000 feet, goes to a scenic overlook, elevation 11,100 feet. The length of the trail is 14,100 feet. What is the inclination grade of the trail?
Inclination or grade just means the angle that it forms with the horizontal. Okay, what do you want me to draw? Yes, today we're doing nothing but triangles, but we need to draw what's there before we get to our triangle. So what are we drawing first?
A straight trail.
So you want to draw the trail first. I would draw the things that the trail starts from and goes to first. So what's it start at?
Alpine Hotel.
So we're gonna draw an Alpine Hotel, so I'm gonna draw a. He doesn't want to draw a building, but I'm gonna draw a building. There's my building. Now what?
Then the scenic overlook.
Okay, scenic overlook is where, above or below? Okay, to the left or to the right? Doesn't matter, so you're driving this boat. Left, so scenic overlook is up here, I'm gonna put a, I don't know what a scenic overlook looks like, something like that. Now what can you draw?
The trail.
Now you can draw the trail, is it straight or curved?
That's straight.
It says it's a straight thing, so there's my straight. Now what?
Label.
Well, I don't really need label, it's a start and finish.
Triangle.
Okay, so how do you want me to finish the triangle?
Put a point down below the scenic overlook.
Okay, directly down,
And yeah, like that,
okay,
and then another line.
okay, so there's my right triangle. Now gotta figure out numbers.
You can put 14,000 or 100 feet on the hypotenuse. Because that's the length of the tree.
It says the length of the trail is 14,100, so that's the hypotenuse, okay? What other information we got?
And then the height of the Alpine Hotel and the scenic overlook.
Okay, so where would that be on the triangle?
Nowhere, so,
Yes, it would.
oh. Can't you just subtract the scenic overlook in the Alpine Hotel?
Yeah, because remember, if I were to draw the actual altitude of the Alpine Hotel, you'd have this dot to the sea level, right? And that would be, what is it, 8,000 feet? Yeah, 8,000 feet. So that's your 8,000 feet, not part of my triangle. And this is the whole thing right here. This is your, what is it? 11,100? 11,100, right? But are these two dotted lines part of the triangle? No, I need this part. And Nick said to get that part, we
Just
subtract the 11,100 and the 8,000, which would give us
3,000.
3,100. And what's the question asked?
The angle.
The angle for what? From the overlook to the hotel, or the hotel to the overlook?
Doesn't matter.
It does. Because they would not be the
Is it
same unless
the
they're both
hotel to
45.
the scenic overlook?
Hotel to the scenic overlook. So that's my theta right there. Okay? All right. Hey, to solve for an angle, what do you need? Do I have two sides? So what's trig function? Inverse what? Why don't you just start with the angle, right? And then label the two known sides. What are the two known sides?
The hypotenuse and the opposite
Okay, and that would be what trig function?
side.
Sine. So sine theta is equal to the opposite, which in this case is opposite
31.
3,100 over the hypotenuse, which is 14,100. Okay, how do we solve for theta?
Inverse.
Inverse sine. Put those numbers in. What do you get? Make sure you were in degrees. If you're in radians, it's going to give you an answer. You just won't be happy. And Abby just did it, and hers was in radians, and then she figured it out. She was in the wrong thing. It's easy when it tells you a negative answer. You immediately write, "Oh, I'm in radians."
Yeah.
But sometimes it'll give you a number you won't even realize you're in radians.
12.7.
12.7 degrees, so about 13 degrees. Okay, you think your picture matches what's in the book? Let's see. What's different? We flipped ours around. He said go left, and they said to go right. So there's your picture, and it matches perfectly. Once again, we didn't really use the elevation of 8,000 or the 11,000. We subtracted those two to get to the 3,100 feet. But the trick behind it was exactly what we just did. Take the inverse sine of both sides, plug it into your calculator, get about 13 degrees. Should have taken this one. This is your last easy one. The hardest thing about today is you just got to make the picture correct, right? Everybody good on that one? All right. Priscilla, you're next. Hey, somebody brought this up. I think it was Evelyn. She said angle of elevation, angle of pre-calculus. I mean, angle of depression.
Is that what it's called? Horizon?
Nobody got the joke. Seth got it. Okay.
Oh,
You
you know,
Uh,
you know how I knew that? Because you were just teaching Vivian that.
I was.
And we were
was.
watching your video on the TV.
Yeah. Okay. So angle of elevation, angle of depression. Everybody screws this up. If she heard the class, this was 2 years ago when you took this. I told you 2 years ago that you must look always in what direction first for angle of elevation, angle of depression. You must always look to the horizon first. Okay. So I got point A, point B. One's above the other, one's below the other one. So if you start at point A, where must you always look first? You cannot look to B. You must look to the horizon first. So I look to the horizon and then I look either up or down at my target. In this case, I'm going to look up. So guess what that angle is? That's an angle of, you got two options. That's an angle of elevation. You must look at the horizon first and then either up or down to your target. If you look up to your target, that's an angle of elevation. If you look down to your target, that's an angle of depression. Okay, flip it around. Now you're at point B. Where do you look first? To the horizon, right? Then you look either up or down to your target. In this case, I'm looking down. That's the angle of depression. People will screw it up because what they will do is they will look at, hey, if I'm at B and it's an angle of depression, then it must look like this triangle. That's not an angle of depression. That's not an angle of anything. That's just an angle, right? But they'll think of beta right here as being an angle of depression. You got to look to the horizon first, right? You have to look to the horizon. They will think that this angle right here is the angle of elevation. That beta right there is not the angle of elevation because you didn't look to the horizon first. Make sure you don't make that mistake. All right. Angle of elevation, angle of depression. I just say this again, the same things. You think you got the idea? Okay. All right, here we go. Who are we on? Priscilla. Woo! I gave you the option. This actually is the easy one. It's just a lot of words. 100% sure. What's the first word mean? What is a meteorologist? The weather. It's a person who does weather. By the way, why is it called meteor? A meteor is a rock from space. So why is it called a meteorologist? Well, I know the answer, so does Evelyn. Anything in the atmosphere is called a meteor. So a meteorologist is a person who studies things in the atmosphere. A rock from space starts in space, but eventually gets to the atmosphere. It's called a meteor. If it hits the ground, it's called a meteorite. All right. A meteorologist.
The height of a cloud using an instrument called a
Ceilometer.
ceilometer consists of a light projector that directs a vertical beam up to a cloud base and a light detector that scans a cloud to detect the light beam.
Okay, stop right there. Let me show you what this means. So you have a device, right, that shines a bright light straight up into the sky. If there's a cloud, then what happens? If there's a cloud, what happens? It's a bright light. Say again? It's a cloud, right? You don't go through a cloud with a light beam. What happens? Like, don't overthink this. I got a big honking flashlight and I point it straight up. It's a really good flashlight. What's going to happen? Why are you overthinking this? I got a flashlight. I point it straight up in the sky. What's going to happen?
Nothing. It's a cloud.
So what's going to happen to the cloud? It makes it brighter. It's a flashlight, for God's sake, right? Okay, so now the bottom of the cloud is very bright compared to the rest of the sky. Over here, off to the side, you have a device that has a pivoting head, right? I don't know what it looks like. I'll show you a picture in a second. But it has a pivoting head that can turn up and down. That's what it's looking for. A bright light. So it sees the bright light, therefore it makes an angle, therefore we can kind of just drew the picture for you. Okay? There's a ceilometer right there, right? Shines a bright light, looks for it. Sometimes they have both devices in one. Okay. Now we got to fill in the information. Go.
Would it be 300 from the beam to
To the detector, right? So 300 is right here. Now what?
So would you have it,
Do we have a triangle yet?
no, but you connect the cloud to the, yeah, and then that angle at the top is 75.
This?
Wait, let me.
Think this through.
Oh, wait, hold on.
The angle has to be measured. If you're saying this is 75, how do we measure it? There'd have to be a person up here measuring it. So where's the 75 go?
By the,
Because this device, the detector, is on a pivot and it goes up and down and a computer reads off the degrees. So this is your 75 degrees. All right. What are we solving for? Yeah, but read the question with the question mark.
the height,
Which side is that?
the right side?
So label it X. Okay, now what? Okay, so what's the math here? Label in relationship to the angle, what are the two sides?
Hypotenuse?
Where's the hypotenuse always?
Oh, adjacent,
Adjacent,
and then the X is the opposite.
opposite. So which trig function?
Tan,
Tan. So tan of
75.
75 is equal to what's tan defined? X over 300. Okay. What do we do? What do we do? What's the math? Solve for X. What's the math?
Yeah, 300.
So that means, yeah, but just verbalize what you're doing. Yeah, but then you're gonna give me the answer. We're trying to do a video here.
Okay. Multiply 300
Times,
and 75.
there you go. All right. So as she gets to the answer, you think our picture is like what's in the book? Hey, we got one perfect. It's exactly like what's in the book. We're not trying to be perfect here. What's the answer?
Um, 1,119.
Reasonable answer?
Yeah,
What's the thing we're measuring? Of a, so if you got 2 feet, would that be a reasonable answer?
no.
I mean, unless it was foggy, right? But, 1,000 feet sounds like a reasonable answer, right? So if we do it, we got 1120 is what you got?
Basically, yeah.
All right, cool. All right, who's left? You volunteered.
I was volunteering.
And I'll say, once again, what was hard about the first one? Just making the picture. The actual math is always straightforward, right? All right, who's up? Is this going to be Matt or Evelyn?
Going to be math.
Matt. All right, go, Matt. This one actually requires a little bit of thinking.
The board of trade buildings in Chicago statute the Roman goddess of wheat.
What the heck is a board of trade? What's the board of trade? Guess what they sell in Chicago at the board of trade? Wheat. Why in the world do they sell wheat in a building? They're not making bread.
So other people can.
It's called the board of trade, right? Here's the story, right? We live in the United States. We have a capitalist society. Yes? People make money off of everything. I mean, everything. Guess what they make money off of? No. Guess what they make money off of? The future. They make money off of the future. Guess what the Board of Trade in Chicago is actually called? The futures market. So I'm not making this up. Here's how it works. You got farmers, right? Farmers grow wheat, right? What happens in the future?
They die.
They make more wheat. Well, how much wheat do they make? Who knows? It's the future. We live in a capitalist society. So guess what they do here? They bet how much wheat is going to be made. Okay? So you ready for this? Who wants to be the farmer? Who wants to be the farmer? So Seth is the farmer. He hasn't planted the wheat yet. It's the future, right? So Seth goes to the Chicago Board of Trade, and guess what he tries to sell? Future wheat that he hasn't grown. Guess who buys it? People who bet on the future. There's only two bets. The bet is either the price is going to be higher or lower. It's a literal bet. Okay? So the farmer is hoping that the price of wheat goes down. Because today he's selling a future product. So he would like to sell today at a price that's going to be higher than the future. I'm making these numbers up, but let's say that he bets the price of wheat goes down. So right now it's selling for $2 a bushel. I don't know what the price of wheat is. I should have looked it up. So $2 a bushel. So today it's going for $2. So today he would like to sell it at $2. But lots of things can happen in farming. Storms, pests, right? We don't get enough sunshine, we get too much rain. Maybe the price of wheat drops, right? But guess what? He's already sold the wheat. He sold the future wheat, and he sold it at $2. So in 6 months from now, when he actually harvests his crop and the price of wheat is $1.50, he sold it at $2. He's made money.
So it's all just based on chance?
It's all, theoretically, there's some smart people that think about what's going to happen in the future. Guess what the people who work at the Board of Trade hope the price does? It goes up. But they're buying the wheat today at $2. Not the wheat that he hasn't made the wheat yet, but they're buying, it's called a futures contract. They're buying the wheat at $2. So if Seth all of a sudden makes the wheat and there's this big wheat shortage, the price skyrockets to $10, guess what he's got to sell it at? $2. So he's lost $8. All of that happens at the Board of Trade. Guess what they actually sell at the Board of Trade? Paper. It's a piece of paper that says, in 6 months, I will buy your wheat at $2. That's all they sell. So 6 months from now, you got to sell your wheat at $2, whether the price goes up or goes down. It's capitalism. It's two-part. It's an equal thing. Somebody's betting the price goes up. Somebody's betting the price goes down. Both parties are happy, right? That's how it works. They sell anything there that the price fluctuates. They sell oil. They sell wheat. They sell gold. They sell oranges, right? They sell cotton. They sell all this stuff because the price fluctuates. But it's called a futures market because you're not actually buying the stuff until many months later. You're just betting the price either goes up or down. And depending on who you are, the farmer or the trade person, depends on whether you want the price to go up or down. Money can be made. Okay, back to our problem. Matt, read.
These two observations are taken. Orange is peak in the center of the building. The angle of elevation to the base of the statue.
Blah, 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 blah. And then
from the angle of elevation to the top of the statue.
You want to see what this actually looks like? There's the actual building. That's the Chicago Board of Trade. Guess what's on the top?
The Roman goddess.
The Roman goddess of wheat, whose name is, there she is, right there. This is the actual statue.
Says it right there.
Says it in the thing. Guess what she has in her hand? She has wheat in her hand. That's why it's a statue on the top. Okay. They sell more than wheat there, but that's one of the things they do. Okay, cool. All right. So, Matt, what are we going to draw? And don't tell me to draw a series. What are we going to draw?
Build
The building. Okay. So here's my building. Yes. And at the top of the building is series, right? The actual question is asking, how tall is series? Okay. Now we got to fill in the rest of this. Is there a triangle there? Ignore the fact that I drew series of triangle. Is there a triangle there? No. We need a triangle. Okay, so what are we going to draw, Matt?
gonna draw the line of 100 feet from the center of the building.
From the center of the building. Now, everyone thinks the center of the building is right here, right? Guess what they actually mean?
The ground level.
From the ground level center outward, how far? 400 feet. Okay, and it says from this point right here, you make two measurements. What are the two measurements?
55.1 degrees
To the,
base of the
so the base of the statue is right here. So from here to right here is what's the angle? 55.1. And then
56.5 degrees
to the
top of the
to the top of the statue, this right here, right there is what, 50, what is it? 6.5, is that right? Does that make sense, what I just drew? Okay, do we have any other information? Okay, are we gonna be able to tell the height of the statue from that? How?
height of the building with the statue.
Oh, so in other words, we're not gonna have one triangle, we're gonna have a big triangle that's to the top of the, and then we're gonna have a smaller triangle to the top of the building. In both cases, the distance is 400 feet from the center of the building to the point where we did our observation, right? But one of them, it's gonna be 55.1 and one is gonna be, what are you gonna do when you get these two answers? If this is X1 and this is X2, what are you gonna do with those two answers? You're gonna subtract smaller from the big one. Does that make sense? Okay, so all we gotta do now is the math of that. What's the trig function? We have this angle theta right here in both cases. We're gonna do tan. So for the big one, it's gonna be tan 56.5 is equal to, which would be, there's the picture right there,
Oh, the height of
which is
the building with the statue.
which is
Excellent.
x of 1 over 400. And then for the small one, it's going to be tan 55.1, is that right? 55.1 is equal to x2 over 400 again. Are these all going to be what? It sure feels like we use tan a lot. Okay. Somebody do the big one, somebody do the small one. What do you got, big or small? Oh, he's already got an answer. Oh, you want to see the picture from the book? Same or different? It's just flipped around, right? But it's the same darn picture we just drew. In fact, they even drew the two triangles just like we did. They didn't call it X1, X2, but what do they call it? B? Yeah, okay. All right. What do we get? Final answer.
Does that say 200?
Yes. Should say 400. No, that's a formatting.
Actually, if we did the math for that.
You're right, but we didn't do the math.
Is it gonna be the math on your slide wrong though?
No, I'm gonna show you the math on the slide is right. What's we get? Final answer. 31 feet. Does that sound like a reasonable height of a statue? It's a pretty big statue, right? 31 feet. Like the length of this classroom is about 30 feet, right? But it's a statue. Matt said we're going to do the top minus the bottom once we find that answer, right? And we found that these were the two values right here. So Evelyn, on my slide, if I do 604 minus 573, I do in fact get 31 feet. Okay. Was that one hard? It was harder than the previous ones because we had two triangles. You had to draw an accurate picture, but it was all that was teased out from the text itself. So the key to this, once again, for the fourth time, is drawing a good picture. Yeah, it'll be something like this. It won't be the Board of Trading series, but it'll be something like that. Okay, we have enough time to do one more, just like I thought. All right. This is the most challenging one up to date. So, Evelyn, this is you.
I'm a calculator.
Hey, guess what this is?
It's a light.
It's this lighthouse. It's the Gibbs Hill Lighthouse. Okay, go ahead, read.
Operation since 1846, the Gibbs Hill Lighthouse stands 117 feet high on a hill.
On a hill. So this is 117 feet. The hill is
245 feet high. Its beam of light is 360.
And that would be these two added together. So the beam at the top, it's 362. Okay.
A brochure states that the light can be seen on the horizon about 26 miles distance. Verify the accuracy of the statement. The Earth has a radius of 3,960.
Maybe you don't know this or not, but basically, how far can you see to the horizon?
I can see
2 to 3 miles. That's it. And then it curves away, you can't see anymore. Okay. This is saying because this is so high that you can see 26 miles. So a ship 26 miles away should be able to see the beam of light. They're just asking, is that true or false? Okay. So what should we draw? What should we draw first?
Maybe the hill.
What should we draw before the lighthouse or the hill?
A sea.
What should we draw before the lighthouse, the hill, the sea? Read all the numbers and tell me what we're missing. The Earth. So we should probably draw the Earth. They gave us a radius. That must be there for a reason. So we should probably draw the Earth first. Okay.
Yeah. He wants to actually draw the Earth.
Well, that's just a circle. You can do it. Okay, now what do we put on our picture? A lighthouse. What am I going to draw for the lighthouse? Okay, there's my lighthouse. Now, clearly, I drew my lighthouse too big. It's just a picture to get a sense for this. And my lighthouse is missing the hill, but it's okay because it already tells you where the beam of light is. Where's the beam of light? 362 feet above sea level. So sea level will be the surface of the Earth, right? Okay. It's stating that I can see how far away.
26 miles.
It's saying just confirm it. So that's an unknown. We got to see if it actually is 26. So which way do you want to see? To the left or to the right?
To the left.
Okay, so
We know to the right.
left works, so does right. Could have gone either way. So there is the distance that we're going to see if it's 26 miles. Yes? Okay, but I don't have a triangle there. It's a right triangle. I got to draw a right triangle. That ain't a right triangle. So where is my right triangle? You're like, yeah, it is. Here's my right triangle. Well, then I just went through a portion of the Earth. I don't know what that distance is. So that isn't the right triangle that I need. Well, if I draw that right triangle, it ain't the triangle I just drew. So where do you want me to draw from?
In the middle.
You mean the center of the Earth?
I'll connect the two.
Yeah, but here's the bottom of it. If I connect the two, I don't have this piece.
Okay, that's not. That's not a straight,
If I connected this to right there, it's not a right triangle.
I said, go up.
Go straight up?
Yes.
Well, then what's that
Oh,
distance?
Are you serious right now?
You mean like
So
this?
serious.
It's from the base of the lighthouse to the top.
From here to here?
You are trying to.
I don't know. I seriously don't know where you want me to draw this line.
Go show them.
Base of the lighthouse to the top.
Do it right here, then you'll get a right triangle.
Yeah, but I don't know what that distance is.
Okay, find out.
I can't.
Why not?
Because I don't know how high that is off of sea level.
Okay, but if you know that long line is.
We don't know that. That's what we're trying to find out. It says it's 26 miles. We don't know if it is 26 miles or not. I need a right triangle. There's one number up there that we haven't used.
245.
245 is,
Oh, wait,
From-
the radius, you wanna see the radius,
so that means I need to go somewhere to the,
middle.
I need to go to the middle of the earth. So put a dot in the center and let's see if we can get a right triangle now. Well, clearly if I go from here straight down, I have a 90-degree angle. And if I connect this to there, I have a right triangle. We do this for the people watching the video. There's your right triangle. Not drawn to scale because we drew the lighthouse way too big. Hey, how big is it from sea level to the beam?
360.
362 what? Feet. Is that a problem? Because guess what the other distance is? Miles. We know from the center of Earth to the bottom of the hill of the lighthouse is 3,960 miles. The but here is that one is in feet and one is in miles. So it looks like this. So guess what I have to do? I need to convert either feet to miles or miles to feet. You got a calculator, you can do it either way, it doesn't really matter. So which one are we gonna do?
The mile.
Feet to miles, so divide by
20.
what? How many feet in a mile?
52.
5280.
How does he know that?
Because you should know that there's 5,280 feet in a mile.
Why
It's
should
gonna affect my
know that?
daily life.
Because we're Americans.
Okay,
We measure things in feet, yards, and miles.
okay, when has a teacher ever required us to know how many?
Well, clearly today,
Okay, yeah.
you should know that 5,200 feet in a mile. Okay, so grab your calculators, divide by 5280. What do you get? It's gonna be a small number.
Can I plug mine in?
Point,
0.06.
are you serious? I was doing the math.
So
right.
0.0.
0.07.
0.07, right? So we need to add that to, so my triangle, I'll draw it off to the side right here. This hypotenuse right here is 3,960.07 miles. My other side is 3,960. I need to calculate the top. Okay, tell me how we're gonna do that. What kind of triangle is it? How many sides do I have?
Pythagorean theorem.
I can use the Pythagorean theorem. Use the Pythagorean theorem on, thank God for calculators, and you'll find out that at 826, it's not 26. So it turns out the brochure is, no, it's 24 point something when you do the math. You can do the math right now. It's 24.3 or something like that. I could be making that number up, but we did it in the other class. Use the Pythagorean theorem on that, you find out it's not 26 miles, so the brochure is wrong. What?
Isn't that false advertising, meaning that the place can be sued?
I'm not a lawyer. I do know that at times you can be sued for making false claims. I'm not sure if this would be one of them.
I would